Okay, so today we're doing lesson 12.2, which has to deal with something called chords and arcs, okay? So if you guys have watched 12.1 already, we've started with circles already. And so you should have already learned what an arc is and what a central angle is and what you know about those, okay? So today we're going to be delving into something called chords and arcs, okay? So the first thing we're going to look at is I want to go ahead and show you guys exactly what I mean by a chord. You guys already know what an arc is. That is the outside of the circle, correct? Yeah. Think of it like I'm throwing something. I have to put more arc on it. There's an arc, okay? Now a chord is basically a line that is in between the two circles, or in between the two sides of a circle. So like if you look at the diameter, does everybody know the diameter? Yeah. That is known as a chord. It's a line that is touching the two sides of the circle. Does everybody understand that? You with me? Okay, that's a chord. So with that being said, there's a couple of rules that you need to remember whenever doing this. So the first one we're going to look at, it says, if you have the same or congruent circles, meaning if you're looking at the same circle or you have two circles that are congruent, if two minor arcs are congruent, then their corresponding chords are congruent. So if you look right here in this example, it says arc AB is equal to arc CD. So if everybody looks here, that means this arc right here is congruent to this arc right here. Does everybody understand that? Yes, sir. So since those two arcs are congruent, that means the two chords that are creating those are also congruent. And so that is also vice versa. So like if you have two chords that are congruent, then that means the arcs are congruent. Or if you have two arcs that are congruent, then the chords are congruent. Does everybody understand that concept? It's pretty simple whenever you understand it. And we're going to actually put that into our examples here in a second. Okay? Does everybody understand that rule? Yes? I hope so. You'll be able to see it here in a second. Okay? The next thing we're going to look at, it says, if a diameter of a circle is perpendicular, what does perpendicular mean?
No, they cross.
They cross at what degree? 90 degrees. So I want you to write 90 degrees above perpendicular right now. So perpendicular means they meet at 90 degrees. It says if it meets perpendicular to a chord, then the diameter bisects. What does bisect mean? Cut it in half. So I want you to put 1/2. It cuts it in half, the chord and its arc. So if y'all look at this example, I have a diameter here that is 90 degrees with the chord, correct? And if you look, there's a little line here and a line here, which means those are congruent. It cuts it in half. So it splits the chord into two equal parts. Does that make sense? It's also going to do the same thing with the arc. So if I have a diameter that is 90 degrees with the chord, it's going to split the arc into two equal pieces as well. It's cutting it in perfect half. Does that make sense? That's all you have to remember. So again, if you have a diameter that's at 90 degrees, it's going to split the chord and its arc in half, or it's going to bisect it. You got to remember that. Okay? All right. And lastly, I'll actually zoom in a little bit more on this one so y'all can see it. I want to make sure we understand it. It says in the same circle or congruent circles, two chords are congruent if they are equidistant from the center. So what does equidistant mean? What do y'all think it means? Equal in distance. Equidistance. It's perfect. It's pretty self-explanatory. So if you look right now, it says AB is equal to CD. So if you look, AB and CD are equal if EF and EG. So if y'all look from the center to the side of my chord, from the center to the side of my chord, if those are congruent, then my chords are congruent. And then also the same thing the other way. If the chords are congruent, then the distance from the center to the chord is also congruent. Does everybody understand that? Okay? As long as you can remember these three rules, these next problems or your skill check is not going to be a problem. Okay? All right, let's jump into example number 1 then. All right, so on example number 1, it tells me the measure of AB is equal to 110 degrees. So if I look, my arc A to B, I want everybody to write this for me, is going to be 110 degrees. Does everybody understand that? Okay? And I need to find the measure of BC, or the arc BC. So what do y'all notice about the two chords right now? They're equal. What does your first rule tell you? Look at your paper. What does it say on the first rule?
In
In the same or congruent circles, two minor arcs are congruent IFF. The corresponding chords are congruent.
Okay, so look, if my two chords here are congruent, if y'all look, what do y'all know about those two arcs? They're congruent. So BC is also going to be 110 degrees. Wow, that was difficult. All I had to do was remember a rule. So since those two chords are congruent, that means those two arcs are congruent. That problem's done. Does everybody understand that? Okay? All right, let's look at my next one. So, what?
Nothing.
What?
Nothing.
What was wrong?
Nothing. Keep going.
Okay, gotcha. Okay, so now on the next one, it says, if the measure of arc AC, so that means from A to C is 150. Does everybody understand that? We need to find the measure of A to B. Does everybody understand that? Okay, what do I know about a full circle?
It's 360.
They're 360 degrees, correct? So that means 360 minus 150, if I end up subtracting that, is going to be 210, correct? You with me? So the distance from A to B to C is going to be 210 degrees, correct? With me? So if I look at these two chords, they're the same measure. What do y'all know about A, B, and B, C? What do y'all know about those? They're both the same length. So that means, what am I going to do at 210? I'm going to cut it in half, right? So what's half of 210? 105. So that means AB is going to be 105 and BC is going to be 105. So A to B would end up being 105 in that instance. So we basically use the same circle to answer two different problems. Okay? So all you guys do remember, if my two chords are congruent, then that means their intercepting arcs are also congruent. Okay? You with me? All right, let's look at example number 2. Okay, look at example number 2. So it says we need to find the measure of C to D, we need to find the measure of D to E, and then we also need to find the measure of the whole thing, which is C all the way to E, correct? Okay, so right now let's look. What is B to D? What is that representing?
The diameter.
Okay, and C to E is my chord. What do y'all notice about those two? They are perpendicular. So Slade already said it. Since they are perpendicular, it is bisecting the chord and it's bisecting my arc. So that means, what do I know about C to D and D to E? They're going to be the same, right? So what am I going to do with 9x and 80 minus x? What did you just tell me? No, what did you just tell me about the two? They're equal. So what am I going to do with the two? Set them equal to each other. So I'm going to take 9x and I'm going to set it equal to 80 minus x. And all I got to do is solve now, right? So I got to get all the x's on one side. So which x do you want to move over?
9x. No, negative x.
So I'm going to add x on both sides, which will give me how many x's?
10x.
10x. And then how do I solve for x now? Divide. So x is going to be equal to 8. So now it's asking, what is C to D? So what is representing C to D? 9x. So what is x again?
8.
So what is 9 times 8?
72.
72 degrees. Done. All I did was 9 times 8. Okay? Now I need to find D to E. What's representing D to E?
80 minus 8.
So what is 80 minus 8? 72. It's going to be the same thing. Y'all know they're the same, right? Okay? And then what's the whole thing from C to E? So what's 72 plus 72? What's 70 plus 70? And then what's 2 plus 2? So 144 would end up being your answer there. So 144. So right now it says we need to find the measure of arc, or it looks like line CU and line QU, and then we need to find the radius of C right now. Okay? So right now, what is something that you notice about the chords? What do y'all notice about the two chords?
Oh, they have the same thing.
But what do you notice? 16 and 16, okay? So if you look back at your rules, what do y'all notice about the third rule? What does it say?
In the same circle or congruent circle,
The two chords are congruent. They're both.
They are equal.
God, you can read it.
Okay, so if y'all look right now, my two chords are congruent. So what that means, since those are equal, the distance from the center to the chord is also going to be congruent. So that means these two are going to be equal to each other. So what I'm going to do, Brock, is I'm going to take 2x and I'm going to set it equal to 5x minus 9, and then I'm going to end up solving. So right now I need to get all the x's on one side, so what do I need to move over?
Minus 2, oh wait, no, minus 5.
I mean, just so you know, you could do that, but I'll go ahead and just subtract the 5. So that'll give me negative 3x equals negative 9. And then how do I solve for x?
Divide.
By
3,
negative 3. So x is going to end up being 3. So now I can find the values of all these. So c to u is being represented as 2x. So what's 2 times 3? 6. Well, I know that since the chords are congruent, the distance from the two are congruent. So what would q to u be?
6.
So q to u, what do y'all notice?
Oh, 60. Wait.
What do y'all notice?
Oh, after 16.
There you go, is
8.
8. There we go. There we go. That was easy. Correct. And now it wants me to find the radius of the circle. I need everybody to pay attention to this. So if you're staring at your screen right now, you're wrong. And just so y'all know, y'all shouldn't be on your computers right now. You should be looking up here. Just so y'all know that. Gotcha? Okay. So the next thing I want to show you, if I actually draw my radius, if I draw it from the center all the way to the connecting point here, what shape am I making here? A right triangle. So what do you think I would do to find the missing side of a right triangle? There we go. I can hear somebody whispering it right now. I'm going to use Pythagorean theorem. So if you look, y'all already found this value, which is 8. You already found this value, which is 6. And so now I would use Pythagorean theorem to find the radius here. So I'm going to do 8 squared plus 6 squared is equal to c squared. What's 8 times 8?
100. 64.
What's 6 times 6?
36.
Which is going to be at 100. Tierney just said it. And then I'm going to take the square root of both sides. So what's the square root of a hundo?
10.
10. So that means my radius of my circle is going to be 10. So I can put r equals 10. Andrew, okay. All right, so lastly, it wants me to find the length of the chord to the nearest unit here, okay? So right in the middle of the circle, what do y'all notice has been drawn here? A right triangle. So if you look, from the center to the chord is 4. From the center to the edge of the circle and then 90 degrees, this is going to be 6.8. So what do I need to do to find the missing side of my right triangle?
Pythagorean theorem.
The Pythagorean theorem. So a squared plus b squared equals c squared. So what is my a value right now? 4. Okay, so I can do 4 squared. I'm trying to find my b, and then what is my c value? 6.8. So literally what I can do here is I can actually do b squared equals 6.8 squared minus 4 squared. Somebody in their calculator, I know you have one, do 6.8 squared minus 4 squared for me. 30.24. Okay, so b squared equals 30.24. Now what do I got to do to get b by itself? I got to take the square root. So somebody take the square root of 30.24 for me. 49, is that what you said? Okay, so now the thing you'll have to look here, I found this piece of my triangle here, which was 5.49. But what do I know about the diameter of that circle and what does it do to the chord? Cuts it in half. So what do I have to do to find the whole chord?
Add 5.98 plus 5, or
Yep.
whatever.
Or double it, right?
Yeah.
So 5.49, I would take away 2 cents from 10. So your final answer would be 9.98. So x is going to be equal to 9.98. Would end up being your answer there. Because I would end up doubling that to find that. Okay? Does everybody understand that? Okay. So now what you guys are going to do inside Schoology, I'm actually going to post it now. There's going to be a skill check ready for this as well. If you guys need any help, please ask for help when you need it, okay?